Alright, let's get one thing perfectly, absolutely, crystal clear before we even think about picking up a screwdriver. The most important tool in your entire workshop is your brain. Its primary job is to keep the rest of you in one piece. Electronics can be dangerous. It's not magic, it's science, and that science involves electricity. Electricity, my friends, does not care about your good intentions. It will zap you. It will start a fire. It will ruin your project with equal indifference. So we have rules. Rule 0. Your personal safety is paramount. Nothing else matters if you get hurt. Before you touch anything, you must unplug it from the wall. I don't mean just flipping a switch on a power strip. I mean physically yanking that cord out of the socket. Is it a battery-powered device? Take the battery out. We never ever under any circumstances work on a device that is connected to a power source. This is the first and last line of defense against a very bad day. You should also be wearing your personal protective equipment, or PPE. Every great build and every great repair starts with a plan. And every great plan starts with information. Before you even think about cracking open the case of your broken gadget, you need to become a detective. You're gathering evidence, building a case file on what went wrong. Rushing in blind is a surefire way to get frustrated, or worse, make the problem even bigger. So let's put on our detective hats and start asking the right questions. Your first and most important source of information is the device itself and its history. What is it doing, or what is it not doing? Write it all down. Your investigation starts with the symptoms. Be specific. Is the screen flickering? Is it completely dead? Is there no sound? Is the audio distorted and crackly? Does it fail to turn on at all? Does it power on for a second and then shut down? Talk to the person who used it last, even if that's you. When did the problem start? Okay, detective work is done. You have your notes, you've done your research, and you have a theory or two. Now it's time to get hands-on. But we do it systematically. We follow a process from the outside in, from the simple to the complex. This methodical approach ensures we don't miss anything obvious, and that we stay safe every step of the way. Confirm the problem yourself. Plug the device in, safely for a moment, and observe the failure firsthand. What you were told might be different from what is actually happening. Confirm the symptoms, then immediately unplug it and remove any batteries. The workbench is now a no-power zone. Your next step is a thorough visual inspection. This is where your eyes are your best tool. Look over the entire exterior. Are there cracks in the casing from a drop? Is a button stuck? Is the charging port loose? Is the charging port full of lint? Look at the cables. After you've done a few repairs, you start to see patterns. Electronics, for all their complexity, often fail in very predictable ways. Understanding these common failure points helps you focus your inspection and testing. It's kind of like knowing where the bad guys usually hide. The number one villain by a huge margin is power. If a device is completely dead, the problem is almost always between the wall socket and the main circuit board. Start with the simplest thing, the power cable. Test it with your multimeter's continuity setting, then check the power adapter. If the cable is good, inspect the device's power jack. These get heavy physical stress and their solder joints crack. With the device open and powered off, gently wiggle the power jack. Do you see it move separately from the circuit board? Look at the solder pins under a magnifier. Do you see hairline cracks forming a circle around the pin? That's a cold solder joint, a smoking gun. Reflowing that solder often brings the device back to life. Check the power supply board for bulging or leaking capacitors. Connectors and cables are another major failure point. At some point in your repair journey, you're going to need to join one piece of metal to another. That's where soldering comes in. It can seem intimidating, but with the right tools and a bit of practice, it's a skill anyone can learn. Let's talk about safety first, because we're dealing with a very hot tool and molten metal. You will use a soldering iron that gets hot enough to melt lead, so it will burn you instantly. Always treat it with respect. Never touch the metal part. Always return it to its stand when you're not holding it. Wear your safety glasses. I'm not kidding. Splashing molten solder into your eye is a life-changing injury. You'll also need a few basic tools. A decent temperature-controlled soldering iron is a great investment. Set the heat around 320 to 360 degrees Celsius, about 600 to 680 degrees Fahrenheit. You'll need some solder, a lead-free spool like SN96, 5AG3, 0CU05, use a rosin flux core. The flux is critical, it cleans the metal surfaces and lets the solder flow properly. You will also need a way to clean your iron's tip like a brass sponge. A clean tip is a happy tip and it transfers heat much more effectively. Lastly, get a fume extractor or at least a small fan to blow the solder fumes away from your face. You do not want to be breathing that stuff in. You've found the problem, you've replaced the component, you've soldered in a beautiful new joint, you're feeling good. But we're not done yet. The final testing phase is just as important as the repair itself. Before you even think about plugging it in, do one last visual inspection. Did you leave any tools, stray screws, blobs of solder? A loose piece of metal rattling around inside a live circuit is a recipe for disaster. Double-check that all internal cables are reconnected. Make sure everything is back where it should be. Once you're sure it's clean inside, reassemble the case. Put all the screws back in. They're not just for looks. They provide structural integrity. They can also provide electrical grounding. Now, for the first power on, do it carefully. Plug the device into a power strip with its own circuit breaker and switch. Place the device on a clear, non-flammable surface like your workbench. Turn it on and observe. Don't touch it right away. Look for signs of trouble, smoke. If you see anything suspicious, kill the power immediately. It's a journey of 1,000 tiny victories. Start by doing it right.